Good evening, sir. Good evening, classmates. My name is Mora Justice. I'm going to talk about Ethereum blockchain. What is Ethereum? Ethereum is the open source decentralized software program that allows you to create and deploy applications. We have the important concept, the cryptograph similar to Bitcoin, blockchain, account two types, and wallet transactions, smart contract, solidity, language used for smart contract development. We have what we call the cryptograph, hash functions, symmetric, symmetric cryptograph, asymmetric cryptograph, and the signature. We have what we call the hash functions. BTC uses SHH 256. Ethereum uses KEKAK 256. Similar to SAH3 variant, won contest for security in 2007, used for all hashing in Ethereum, derived differently than standard block cipher-based hashes or previous SAH functions. We have the digital signatures or the digital proof. Same uses case cryptographic method ECDSA as BTC. Signer uses private key to generate a signed message. Signed message can be verified using a signer public key. Hashes are signed in Ethereum, not the data itself. Blockchain, fully distributed database like BTC, will have the advantages: highly secure, transparent, and immutable. We have the disadvantage: scaling and performance. We have the Ethereum blockchain. It consists of three elements: transaction list of all transactions included in a block header, group of 15 elements. We have the UMA list of all uncle blocks included. We have the what we call the uncles or the UMAs. Sometimes valid block solution don't make mention any broadcast block up to 6 previous blocks back with valid proof of work and difficulty can be included as an uncle. Maximum of 2 can be included per block. We have uncle block transactions are not included, just headers, aim to decrease decentralization and reward work. Uncle headers can be included in main block for 1/32 of the main block miner's reward given to said miner. Miners of uncle block receive percent of main reward according to U base n plus 8 minus B base n multiplied by 5/8, where U base n and B base n are uncle and block numbers respectively. Example: 1333 plus 8 minus 1335 multiplied by 5/8 equals to 3.7 Ether. All blocks visible like BTC. However, blocks have a different structure than BTC, as you can see in the picture. We have blocks faster than BTC and reward indifferent every 12 seconds. 5 Ether main reward. Miners can make a bit more by including uncle blocks, 1/32 of an Ether each, up to 2 maximum, or maximum of 2. Uses Etherhash mining algorithm, different from Bitcoin, helps mitigate SIC and GPU advantage, involves smart contract execution. Difficulty is adjusted every block, not every 2 weeks. This is an important identifier for the uncle blocks. We have the key differences. Block key tracks of balance, not unspent transaction outputs like BTC. Merkle Patricia tries use. They have 3 branches compared to Merkle 3.2. We'll transition from proof of work to proof of stake with Casper protocol. Validate all transactions. When we talk about Ethereum nodes, it validates all transactions and new blocks. Operate in a P2 fashion. Each contains a copy of entire blockchain. Light clients store only block headers. Provide easy verification through three data structure. Don't execute transaction. Use primarily for balance validation. Implemented a variety of language, which is Go or Rust, etc. We have what we call the account and wallet. Accounts are of two kinds: external owned account and contract account. Consists of a public/private key pair. Allow for transaction or interaction with the blockchain. Wallet, a set of one or more external accounts used to store and transfer Ether or Ethereum. External account has an associated nonce, amount of transactions sent from account, and a balance. Code hash has an associated amount of code, that is a computer program for a smart contract, hash of an empty string for external account. Storage root is storage hash of Michael Patricia trie of associated account data. We have the contract account. Ethereum account can store and execute code, has an associated nonce and balance. Code hash, hash of associated account code. Storage root contains Merkle tree of associated storage data. We have the examples. The private key, these are the examples, the keys. Ethereum private keys are 66 character strings with 0x appended. Case is irrelevant, same derivation through ECDSA as BTC. We have the address, the key. The Ethereum private key is mapped to address directly. Simply the last 40 characters of KCAC 256 hash of the public key. Address is 42 characters total. Append 0s to front. We have the transaction. A request to modify the state of blockchain can run code, contrast, which change global state. Contrast only balance up to date in BTC. Signed by originating account. We have the types. Send value from one account to another. Create smart contract. Execute smart contract code. We have the Ether denomination, we lowest denomination, named after Wei Dai, author of B Money Paper 1988. Many core concepts used in BTC implementation, which is the quintillion. We have the Sasbo, next denomination, named after Nick Sasbo, author of BitGold. We have Finne, second highest denomination, named after Hal Finne. Received first TS from Nakamoto. We have what we call the smart contract, executable code, turning complete, functions like an external account, hold funds, contain interact with other accounts and smart contracts, contain code, can be called through transactions. We have the code execution. Every node contains a virtual machine similar to Java, called the Ethereum Virtual Machine, EVM. Compile code from the high-level language to byte code. Execute smart contract code and broadcast state. Every full node on the blockchain processes every transaction and stores the entire state. We have the halting, or what we call the gas. Halting problem, infinite loop. Reason for gas. Problem cannot tell whether a node or a program will run infinitely from compile code. We have the solution. Charges fee per computational step to limit infinite loops. Stop flawed code from executing. Every transaction needs to specify an estimate of the amount of gas it will spend. Essential measures of how much one is willing to spend on a transaction, even if buggy. We have what we call the gas cost. Gas cost price, current market price of a unit gas in winner. Check gas price here. It's always set before a transaction by user. We have what we call the gas limit, maximum amount of gas users is willing to spend, helps to regulate a load on network. We have what we call the gas cost used when sending transaction. It is calculated by gas limit multiplied by gas price. All blocks have a gas limit, maximum gas each block can use. We have what we call proof of work versus POS, proof of stake. Ethereum in the process of moving to proof of stake. The approach does not require large expenditure or computing energy. Miners are now validators and post of deposit in an escrow account. The more escrow you post, the higher the probability you will be choosing to nominate the next block. If you nominate a block with invalid transaction, you will lose your escrow. Ethereum in the process of moving to proof of stake. One issue with this approach is that those that have the most Ethereum will be able to get even more. This leads to centralization eventually. On the other hand, it reduces the chance of 51 attack and allows near instant transaction approval. The protocol is called Casper, and this will be a hard fork. We have other approaches to consensus as listed. Then Ethereum block headers, hash of include OMA stores in block headers, state root in the hash of a Merkle tree that holds all account information, similar to storage structure for transaction and receipt. State root, transaction root, receipt, stored in data structure known as Merkle Patricia tree, similar to Merkle tree used in BTC, but with 3 leaves per node. Tree is cryptographically secure as alteration of a leaf of intermediary. Nodes result in different root hash. State root. Each node in the state root tree represents an Ethereum address. Each address has 4 components. We have what we call the nonce, list of number of TX from the address. We have what we call the code hash, hash of associated code. We have the storage root, Merkle Patricia tree root of account storage content. We have the balance of account. Then we have the Ethereum difficult bump, spike increase in mining difficulty, introduced attempt to reduce number of miners, aim to predate shift of algorithm from proof of work to proof of stake. Thank you for listening and remain blessed.